Welcome, geometry students. Today we're going to learn how to find and apply the volume of prisms and pyramids. So in order to find the volume of a pyramid, we're going to find the product of the area of the base with the height divided by 3. Now that's one way to show the formula. Another way to show the formula is the volume equals 1/3 the area of the base times the height of the figure. So really it's up to you which formula you prefer to use. I personally prefer this formula, but they both do the same thing. It just is a matter of how you like to show your work. So capital B is still the area of the base, and H is still the height of the figure. So keep in mind a pyramid and a cone, they both meet at a point. So in this case we have a triangular pyramid. We have a triangle for the base and it meets, all of the 3 lateral faces meet at a point here. Now when we're calculating the volume of a solid, we're looking for how many cubics fit inside of the object. So the reason why we do the volume equals 1/3 the area of the base times the height is because we're really only taking up 1/3 of the volume or of the space as a prism would be with this same base. So we're basically doing what we did in the previous lesson, but we're multiplying it by 1/3 because we're meeting at a point. So we're going to go ahead and find the area of the triangular base. In this case, we're given the base and the height, which is really nice because they both meet at a perpendicular right angle. So we can do 1/2 base times height right away. So 1/2 4 times 6 tells us that the area of the base is 12 square units. Now the height of the figure, be careful. When we worked with surface area, we used the slant height. This is not the slant height. We actually want the perpendicular height that's going to be intersecting at the center of the base. So in this case, we do not want the slant height. We want the perpendicular height. So that's a height of 9. So again, the height goes from the point where the lateral faces meet to the center of the base. Well, now we just plug those into our formula. 1/3 times 12 times 9. And we find that the volume of this particular pyramid is 36 cubic meters. Okay, volume of a cone is going to be the exact same formula because even though the base is circular, it's still meeting at a point. So we're going to use the circle formulas for area of a circle and perimeter of a circle when needed, but we really are using the exact same formula as when we do the volume of a pyramid. Again, I prefer the 1/3 area of the base times the height. And capital B is the area of the base. And H again is not the slant height, that would be L. This is the height of the figure. So in this case, we would calculate the area of the base, and then we would use the fact that the height of the figure is 12 feet. That's the perpendicular height again, not the slant height. All right, so let's find the volume of this solid. Now, if you notice, this is the first time we've seen an oblique solid, meaning we have our figure, it's not necessarily a right figure, but it's still going to use the same formula. So when we look at calculating the area of the base, we're going to use pi r squared, or pi times 2.2 squared. So we find the area of this base to be about 4.84 pi in exact form. The height of the figure is the perpendicular height, and that's what's shown here. So the perpendicular height is 4.5 centimeters. Now that might look like it's a slant height, but in this case, because this is an oblique figure, kind of got pushed over, the slant height and the perpendicular height are the same. So now we're going to plug into our formula. Don't forget, anytime it meets at a point and doesn't have two congruent bases, I need that 1/3. So 1/3 times 4.84 pi times the height of 4.5 is going to give me the volume of this cone. So this should be approximately 22.81 cubic centimeters. All right, the last example asks us to find the volume of a cone. So we're going to work this the same way we did the previous problem. The only difference is we don't know the radius. So we're going to start in the same regard using our formula, 1/3 the area of the base times the height. Well, when we look at this, the area of the base is just pi r squared. However, we don't know that radius. So we need to consider, do we have any information so that we can find that radius? Well, in this case, we're given the height and we're given this 65-degree angle. So what we can do is use trig to go ahead and find the radius. So since I'm finding the adjacent leg, knowing the opposite leg, I'm going to use a tangent function. So tan of the 65-degree angle is equal to the opposite, which is 16, over the radius, which is r. So if we go ahead and cross multiply, we're going to find that the radius is about 7.461 feet. Now that we know the radius, we can proceed just like we did in the previous problem and use pi times 7.461 squared. And that works out to be about 55.67 pi. Now the height was given to us, and again that's the perpendicular height. So that's 16 feet. And now we just simply plug it in. 1/3 times 55.67 pi times 16, and if we multiply that out, we should find that the volume of this particular cone is 932.68 feet cubed. My only last comment is, if they don't give you the height, and let's say they do give you the slant height, just keep in mind we can still use Pythagorean theorem to find the perpendicular height. So that's an option as well in some of our problems. Go ahead and try the You Try Nows. If you have any questions on those, please let me know the next time we meet. Have a good day.